Hello everyone, my name is Yui and this is my submission for Keyloop coding challenge. I picked scenario B, the intelligent inventory dashboard. The job in plain English. Dealership manager need one screen that shows every car on the lot. Let them filter it. Make anything sitting longer than 90 days stands out and let them write down what they plan to do about it. And that note has to be still be there tomorrow. So at its core is a small crude app with one interesting business rule and one interesting filter surface. I designed it to match that, not to look like a system overscale. And in the next few minutes, I'll walk you through the design, the implementation, how I work with AI on it, a quick demo, and what I learned. The first step is the system design walkthrough because the requirements is vague, so I need to make some assumptions. Multi dealership from day one, every vehicle is scoped to a dealership ID. Authentication isn't built, but the data model is ready for it. Age is equal to now minus receive at. The 90-day threshold is a config value, not a magic number. Inventory is read heavy. Managers need to view far more than vehicles arrive, so I optimize for fast reads and simple write. One current status per vehicle plus history. Append only audit log alongside a the normalized current status column. Realistic scale hundreds to a few thousand vehicles per dealership, not a web scale problem, so don't overscale it to a million. Uh, the next part is architecture diagram. So the stateless Express TypeScript API in front of one PostgreSQL database with Pinot structure logs and the prompt client red metrics. When traffic grows, I run more API copies behind a load balancer. Postgres scales vertically and later with read replicas. The key design call is compute is aging on read, not storing it its own way. Correct, no nightly cron job, and no cost is one subtraction per row. You see the data flow, and the rise happened in a single transaction. Insert into the immutable vehicle actions history, update the denormalized current status on vehicles. History gives me audit. The column keeps the dashboard query a single select with no join. Indexes are on dealership ID, receive at, and dealership ID, make model, the two queries that actually matter. Things I deliberately did not pick: microservices, no microservices, no message queue, no Redis, no GraphQL, no Kubernetes. Each one would be operational task with no benefit at this size. I'd rather start small and add things where the metrics tell me to do. The next step is the demo. So this is the demo. Uh, I implement the front-end layer and I use a React invite TypeScript in strict mode, style with time tailwind, data fetch with stack query, and backed by an Express mock backend plus mock service worker for the browser inception. Tests are with Chess and TS Chess. So I prepared this markdown prompt for the anti-gravity to prepare to build the web application for me. So the architect that with the React query and the mock service worker intercept API call, email remutation support. And then and this is the web. Um, we have three status card here: the total vehicle, the aging stock, and the fresh inventory. So the dealership 42. So the this dashboard is internal scope within a one specific dealership ID. And the make, we choose the make of the vehicle. For example, I choose Chevrolet. Oh, sorry. And I can filter out the aging vehicle which is sitting in the inventory more than 90 days. So we have four aging stock of Chevrolet. We have one fresh in inventory. Add paging here. And we can edit the transaction like price reduction plan, like reduce and change, save action, and it change to the save price reduction. Additionally, we can have a dark mode and light mode here. We can show the model, example, model 12, model 13, model 45. Yeah. And the next part is how AI collaborate with me. I treated AI as a fast but literal pair, never as the author. So my loop had three rules: design before code. I wrote the problem in my own words first, in build.md and the system design.md before letting an AI to talk at me. Then I ask for critique, not solutions. Prompt like my data model, what I am missing. The next is generate white and then cut it. So I ask for every observability signal you would want for the system like this, and then I delete it. About 70%. Picking what not to include was my job. And if I ever verify everything from AI. What I learned and challenges. So three things. I have learned three things. The harder part of the design wasn't what to add; it was what to leave out. How the AI was happy to suggest Reddit, Kafka, microservices, but I don't think they are necessary. Computing is aging on read is more disease that pays back constantly. So no crunch job, no stateless. The boring is good. And challenges: getting mock service worker and express mock server to agree on the exact same response. Um, I solved it by making both consume the same type from source types.ts. The other one was display with AI output. It's easy to accept a clinic looking and quietly adds defensive code for impossible errors. I rejected those passes and asked for the shipless version every time. Thank you so much for take time to review my submission.